Welcome intellectuals to Siding Institute. In our today's video, we're going to do a number of questions on measurement and units, covering all what you've covered so far. Okay, because I've been receiving a number of complaints about how difficult you are finding yourself in handling a number of questions on this topic. Okay, so the first thing you need to know is this. Here is something you need to know. You need to know the dimensions of length as the first thing before we start doing any questions. You need to know the dimensions of length. Okay, the dimensions of length. So the dimensions of length is capital letter L. Okay, is capital letter L, and its units is meters. What about time? Time is capital letter L in square brackets. Also the units is seconds. You need to know this. What else? You need to know about mass. So these are three fundamental units which we call basic units, which you need to know because we are going to use this to drive other units. Okay, the mass is capital letter M. The unit is kg. What about velocity? How can you find now the units of velocity? Okay, let's talk now about velocity as this is our number one. So you should take note of this, guys. What about our velocity? Okay, so velocity is defined as the rate of change of displacement over time. Okay, so the displacement is same as length. Okay, so x is going to be replaced by L and t by time to show the dimensions of time. So this is how you find the dimensions of what? Velocity. But you can also write this. You can also write this by taking t on top. Okay, taking t from the denominator to the numerator, it's going to gain a negative since it is positive. Laws of indices, this is what you need to know. So how about the units? How about the units of velocity? So when you look at this, okay, since on top we have L, which is the length of length, the units of length is meters, and down we have T here as seconds. So this is why you find the units of velocity to be meters per second. It is same even here. You can write it as okay, you can write it as our meters per second, okay, raised to the power negative because of this. These two units are one and the same. Okay, how can you now find the dimensions of acceleration? Acceleration is defined as the rate of change of velocity over time. Okay, so here is what you are going to do. Velocity, you already know to say that velocity is given by this. Okay, well, let me use this part. Velocity is given by, let me just go ahead and use this. It's given by this as the dimensions. Then we are dividing by time, which is now t. Okay, so what you are going to do now, we are going to take, okay, we are going to take t on top. Taking t on top, guys, it is going to gain a negative. It is going to have t to the power negative 1. Now you can see that we have t and t. Okay, when some bases are multiplying, guys, when some bases are multiplying, we add the powers. This is what we are going to have m b plus a. So even here, t times t are going to have t squared, but because of the negative there, we're going to have t to the power negative 2. You should take note of this. These are the dimensions we're going to be using. That's why I started by showing you how you can drive different kind of units without just jumping. How can you now find the dimensions of frequency? Okay. All right, so let me also show you the units of acceleration. I just almost forgotten the dimensions. We know that the dimensions is L, then t to the power negative 2 there. Okay, t to the power negative 2. That's why the units of acceleration you always see, L is for meters, you already know, and ht is s to mean seconds to the power negative 2. These are the units of what? Acceleration. That's why if you want to remove the negative here, you write as meter per second square. It's one and the same. What else do you need to know? You need to know how to drive the formula of frequency. These are things you'll be asked about, guys. Okay? How can you drive the formula for frequency? Frequency is given as the inverse of time. Okay? So the dimensions of time, now the dimensions of time is t, capital letter T inside the bracket. Taking this on top, okay, taking that on top, it's going to gain a negative, and it's going to be t to the power negative 1 there. And these are the dimensions of what? Of frequency. If you are asked in a question to use the dimensions of frequency, that's how you go about it. Now, what about the units of frequency? The units of frequency now, since time, the units of time is seconds, we're going to raise now to the power negative, okay? And this is equivalent to 1 hertz. So saying what is, or second raised to the power negative 1, it is 1 and the same. Let's go ahead. What else do you need to know? We can talk about area, okay? Area is given by L times B, okay? And the dimensions of L and B both are length, okay? L is length, okay? Even B is length. So the dimensions for length is going to be L squared. What about the units of length? The units of length, now since we know that L is for meters when it comes to units, we are going to say the units of now of area is meters squared. Guys, you don't need to miss this. If you miss that, you are going to have difficulties when we start solving questions. Excuse me for that. What about volume? You need also to know about volume. Volume is also given by, mainly volume is defined as base area, okay? Base area times height, where our area, we already know to say our area is L squared, okay? Is L squared, and our height is actually the length, guys, and you already know to say that the dimensions of height of length is L. So this L times L, are going to have our L to the power 3. So this is the dimensions of volume. So you can see now about the units, you can tell to say that L is for M, so it is cubic meters. That's why volume has cubic meters, guys. You shouldn't confuse. Let's go ahead now and drive more units. We still need to drive more dimensions, guys, for other quantities. Okay. What about density? What about density? Okay, density is denoted by the capital letter, the letter which looks like P, which is a rho, but actually it's not P. So Density is given by mass over volume. What you need to know is this, okay? Mass, the dimensions of mass is L, is capital letter M, okay? This is what we are talking about. And the dimensions of volume, it is L to the power 3. You should take note, this is volume, not velocity. So we go ahead now and take this on top. When we take this on top, it is going to gain a negative. If it is positive, it becomes negative, and vice versa. These are the dimensions of density, guys. Okay, so the units now, we derive the units from the dimensions. So this is actually for mass. Okay, mass is kg multiplied by L is meters, now to the power negative 3. That's why in some cases you see kg per cubic meters. We just eliminate negative and include a fraction there. Just go ahead and drive. What else do we need to know? Guys, you miss this concept, you miss everything. Let's go ahead and drive the dimensions of force. Force is given by mass times acceleration. Okay, the dimensions of mass, guys, is capital letter M there. And acceleration we are from solving. Okay, acceleration, I'm sure you are taking some notes so that you don't get confused. Acceleration is given by L, then t to the power negative 2. So these are the what dimensions of force. What about the units of force? So M is for kg, and L is for meters, and T is for seconds. So these are the units of force, and this is equivalent to 1 Newton. So when you see 1 Newton, it's same as this one, because I've prepared one question from a certain exam question which we are going to apply this concept. That's why I mentioned that. So it is important, guys, that you are knowing how we are coming about these things. Let's talk about now momentum and impulse. Okay, let's talk about momentum and impulse. Momentum and impulse, guys, are given by the same formula. You are going to understand this when we start doing collisions. Momentum. So what we are going to do, guys, is this. Okay, momentum and the collision both are given by the formula mass times the velocity there. Okay, so mass, the dimensions, first we are finding the dimension is capital letter M, and the velocity is given by L chi to the power negative 1. You already know this. So these are the dimensions now for momentum and impulse. How can you go ahead now and find the units? So the units now are given by, okay, the units are given by mass is for kg there, length is for meters, and t is for seconds. So you can see that this is very close. There is only a difference of -2 here and -1. So you shouldn't confuse the units of force and momentum and impulse. Okay, what else have we remained with? Let's talk about the units of for work. Okay, let me try to check if I still have a space there. Okay, I still have space. Okay, so what's the units for work? So work is given by mdh. Okay, this is what you need to know. So let's drive now this. You know that g is the acceleration due to gravity, which is same as acceleration. So we're going to use the dimensions of acceleration, which is L g to the power negative 2. Okay, mass, m is for mass, and we know that this is capital letter M. What else? Height is length. Okay, height is just length, which is capital letter L. So we are going now to replace. Why there is M, we put capital letter M there, and why there is G, we say we are going to replace by L and G to the power negative 2 there. Then height is actually L. What are we going to do, guys? Okay, here is what we are going to do. As you can see there, L and L are multiplying out. Okay, L and L, this has are like them, so we are going to multiplying L times L, we are going to have L squared. L squared, then T there to the power negative 2. These are dimensions of force. I mean the dimensions of work, which you need to know. Now what about the units of work? Okay, the units of work now is going to be, since M is for kg, then L is for meters now squared, then T is for seconds there to the power negative 2. And this, guys, is equivalent to 1 joule. Okay, that's why the units of work is 1 joule. Writing this, it's one and the same. This is the same emphasis I was also given about force over newtons. Okay, so let's now start solving questions on dimension analysis. This is everything you need to know, guys, about dimension analysis. So this question I took directly from your lecture slide. The question reads, what are the units of volume? This is our first question. Okay, the units of volume first, before I even go, this is what I was talking about. The units of volume, let me write it here. Okay, since I still have space, the units of volume now is going to be L to the power, because the dimensions is L to the power 3. This is what we were doing. So the units is meters to the power 3 there. It's cubic meters. So the other question you are now going to ask yourself is, now suppose that the other student tells you that a cylinder of radius r and height 8 as a volume given by this formula. Okay, as a volume given by this formula. This is the formula now of that student. So the student gave us this formula. So you are asked as a student who have learned what? Dimensional analysis. How are you going to prove this student wrong? Okay, so using dimensional analysis, you are going to prove this using what? Using units. Okay, you know that the units to the left hand side there, the units of V here is already cubic meters. Okay, what about to the right hand side? The radius is just length. Okay, radius is, it is just length, and the units of radius, it is meters, so I have meters to the power 3 there. And height, it is just also measured in meters. Okay, we have meters there. So here we're going to have meters to the power 4 once we multiply out. Now you can see that the units from the left hand side is not equal to the units to the right hand side. So that means to say that this formula our friend gave us was what? Was wrong. So this is how you prove the student that wasn't correct. let's go ahead now and do. Let's go ahead. What's the other question have you been given? I've been given to find the question 3 or question 2. Can there be a physical quantity that has no units and dimensions? Yes. Okay. Give an example if yes. So my answer is yes. I'm going to explain this. An example I can give is refractive index, grade 12 work lenses. Refractive index. So what you need to know that a physical quantity can be dimensionless, okay, if it is a ratio of two quantities with same dimensions. So what is going to happen is just like the way you need to know that if a ratio of meters over meters are going to cancel out and you are going to have one. What you need to know about a constant, any number is dimensionless. So this is what happens to refractive index. You know that refractive index is the ratio, okay, the refractive index there. The refractive index is a ratio of the volume of speed of the volume of light in vacuum, okay, the volume of light in vacuum, also the volume of light in what, in media. I'm not going to explain the equation, the formula, because it's not what we are dealing with. I'm only interested with the what, the units. As you can see, the volume of vacuum, though in different media, you need to know that volume will be always in meters per second there. Over down here, volume in media will also be in meters per second. That means to say these meters and meter per second are going to cancel and you're going to have one. So this refractive index, it is one of the quantities which has what, which has no units, plus it is dimensionless. So the answer for you, just to say yes, and the example, it is refractive index. If you are asked to show why, you do this like the same way I've just shown here. You write the formula, you also show how the units are going to cancel out. What about the units of force? This is what I was doing, okay? Force is mass times acceleration. Go ahead and do the dimensions of mass is m. What about the dimensions of acceleration? From solving to say it is L t to the power negative 2. This is what I was doing. Now for this question, guys, for this question 4, each of the following question was given by a student during an examination. This is from tutorial sheet 1 for the last academic year, which is also very important to you guys. Like I used to tell you that tutorial sheets are one and the same. They just edit the what? They just edit the year. So this question I did in the first videos I sent you. So if you want to watch that video, I'm going to share the link in the description section so that you may watch also the explanation to this. It is very, very simple. Okay? Or let me try to answer one so that at least someone may not get confused here. I'm going to show you the one which is simplest, the simple one. Okay, so let's use this formula. Okay, let's use this one. I prefer using this one because it is simple. So we have been given to say that all these equations were given by a student during an examination, okay? And you are asked to explain why the equation cannot be correct, okay? To know if the equations are correct or dimensionally correct, you need to know that the dimensions of the left hand side there should be equal to the dimensions of the right hand side. So we're going to deal with the left hand side first, mass times acceleration. So the dimensions of mass there, okay, the dimensions of mass is m there, and the dimensions of acceleration is L t to the power negative 2. These are the dimension to our left hand side. What about the dimension to our right hand side? To our right hand side, we have v squared. Okay, the dimensions of v is L, then t to the power there, negative 1. Now, because of this is squared there, we're going to square everything. We're going to have here squared, here also squared there. As you can see, the dimensions of the right hand side here, it's not equal to this one, not even closer. So we're going to say the right hand side dimension is not equal to the left hand side. Okay? So hence, this equation was not correct. So go ahead and show all this. These questions are not difficult. What you'll be doing, guys, the first hint I can give you is that this half, any number in front or any trigonometric ratio you'll be seeing in front is dimensionless. This is what you need to know about dimensions. So what you're going to be doing is that you're going to replace m by the dimensions of m, v by the dimension of that, and then you simplify. After you simplify, you're going to compare. If they are correct, you're going to say that they are not dimensional correct. And I solved the question. Make sure when you are doing this question, you just found all are dimensionally inconsistent. They are not correct. Okay, let's now go ahead and do other questions. If you are tired, the way we hold videos, guys, because this is the wrong video. If you are tired, go ahead, pause the video, rest some. You proceed after 10 minutes. Today I aim to finish this topic. We've been talking about this topic since you guys just reported, even those who registered before reporting. So show that the expression, okay, show that the expression v is equal to v initial plus acceleration times time is dimensionally correct, where v final and v initial represents velocity, a acceleration, okay, a acceleration, and t to represent time interval. Okay, so here is how we go about it. So as usual, we are going to find the dimensions to our left hand side, also to our right hand side, then we compare. So to our right hand side, we only have v, and the dimensions of v is L, which is velocity. You see now, guys, how important that part I started when I was introducing dimension analysis. Okay, what about to the left hand side? We have v initial. Since this and this are all representing velocities, guys, v initial and v initial, they are all representing velocity, so the dimension will still be the same, over t to the power negative 1. Okay, so for you guys who are used to use fractions, go ahead and use L over t, because somebody is going to be asking me why I'm using this when in your lecture side there is this. Okay, it is one and the same. Okay, so let's now go and deal with acceleration times time. What is acceleration times time? Acceleration, we already know to say it is L, then t to the power negative 1, negative 2. What about t? T is t now, capital letter, raised to the power. It is positive 1 now. So here is how we do things, guys. T times t, okay? We are going to have just a single t there. This is how you simplify. We're going to have t there, but raised to the power. Raised to the power, we have negative 2, and we have a silent one. So I'm going to add negative 2 plus 1. It is actually negative 1 here. So we're going to have negative 1. So now I want you to look at this, okay? I want to look at this. The equation is v is equal to v initial plus acceleration times time. Now look at this. This is just the same as this. Also the same as this, and I was saying that this can also be written as this. So V is L over T there. Okay? Also here, it is L over T. Also here, it is L over T. Let me put now the dimensions so that I may not put the square in the dimensions. Okay, so as you can see now, since we have a positive here, we are going to say our L over T there is going to, this plus this is 2 L over T. Okay, so here is what you need to know. The question is just asking to show if the equation is dimensionally correct. So you need to know that these two, a number in front is always be a number is dimensionless. So this can be simplified further to be T is equal to L over T, because this constant is dimensionless. So you can even tell to say our left hand side is equal to our right hand side. Hence, the equation is what? Is correct. But because of this constant, guys, though it is correct, it is physically incorrect. Okay? Because an equation which must be physically inconsistent, it must just have an equation which will end like this. But for your question, guys, end by saying it is dimensionally correct. But if you are asked to show if it is dimensionally, it is physically correct, it must just have the same dimensions. L over T is equal to L over T. All right, let's go ahead now and do the other question. Here is our question. The period of a simple pendulum, defined as the time necessary for one complete oscillation, is measured in time units and given by the formula. So we have been given the formula of a simple pendulum to be 2 pi, the root of L over D. In semester 2, guys, you see how important this equation is. So where L is the length of the pendulum and G is the acceleration due to gravity in units of length divided by time squared. So show that the equation is dimensionally consistent. You might want to check the formula using the keys at the end of a string and a stopwatch. So this is not necessary. Let's just show if the equation is dimensionally correct. Okay, so here is how we are going to do this, guys. So the first thing is that the constant is dimensionless. Okay, so our equation we are going to check now, we are going to remove the dimensionless here. We're going to remain with L over G there. Okay, so now to get rid of the square root, guys, okay, to get rid of the square root, we can square here. I want to have, we are going to have T squared there. We are going to have T squared. Squaring this, the square root is going to cancel. We're going to remain with L over G. Now let's do this. Let's do this. What are the dimensions to the left hand side? We have T squared there. And the dimensions of T, guys, the dimensions of T, let me try to mute some guys here. It's too much. They have sent too much messages. Okay, so T squared, guys, T is for time. Okay, so the capital letter T now to represent time, now the square root. This is our dimensions to our left hand side. Let's go ahead now and do the dimensions of L over G to our right hand side there. Here is what we do. We know that L is for length. Okay, we say L is for length. We are going to divide now. We are going to divide by D. D is acceleration, guys. and the acceleration is L, then t to the power negative 2. T to the power negative 2 there. So I'm going to write L t to the power negative 2. No one can be confused when I say L and L is going to cancel, and you are going to remain with 1 over t to the power negative 2. Taking this on top, guys, it is going to be positive. Since it is negative, we're going to have t to the power negative 2. I mean positive 2, yes. I'm sorry. So as you can see now, this and this are just one and the same. So you are going to say that the dimensions from the left hand side is equal to the dimension to the right hand side. Hence, the equation is correct. It's dimensionally correct. This is how, guys, you should be dealing questions on dimension analysis. All the questions are one and the same and all very simple. Okay. We try to check for more questions. We have a number of questions which we are going to deal with today. Okay, this is also from Toro sheet 1. So, suppose the displacement of an object is related to time according to the expression x is equal to bt squared. What are the dimensions of b? This is our question A. To find the dimensions of b, guys, we're going to make b the subject of the formula. We divide both by t squared so that t squared may cancel. Okay, what we are going to remain with? We are going to remain with our b to be equal to x over t squared. X is displacement, and the displacement is actually length. Okay, so x is going to be replaced, guys, by L, the dimensions of length, and the t, it is time, so I'm going to have t squared. So this is the dimensions of b. If you want, you can take now our t on top, which is going to gain a negative there. As simple as this. So I'm sure, guys, by the end of this video, you are going to know everything about the measurements and units, and you are going to handle any kind of question. I don't think anyone can get struggled after watching this video, because I've corrected all questions which you may be asked. So let me try to take this time now to tell you that we don't only do physics, guys. We offer tuitions both in biology, Bio 1-1, for you semester 1 students, NSC students. We also do MSM 1-1. We also do Chem 1-1 and this Phys 101 we are doing. So at Siding Institute, guys, we make sure we break things like the way I'm doing for you to understand things very simple. We break things very well, and you're going to make sure you understand. Okay, so tuitions, we offer tuitions, guys, at only 60 kwacha. 60 kwacha per course each month. And I can tell you, as soon as you register with us, you're going to be accessing all the videos for past papers. You won't struggle to look for solutions for past papers, tutorial sheets, understanding concepts. All has been covered for you. So what you're going to do, guys, if you are interested, just inbox me at this number. Once you register, we're going to add you to the group, which you're going to start attending lessons and receive the lessons which you missed. Okay, so let's go ahead and do question 2. Question 2 is, I think there's question 2 there. Down here, I think I made 2, yeah. That means no. Let me drag down here. I thought I uploaded 2 questions there so that I may answer from the same parts. So let me do also question B from here. Question B, I think it is the simplest on a dimension analysis. The question I've ever seen to be simplest. Only with a very simple trick there. So the question is a displacement is related to time as x is equal to sine 2 pi frequency times time there. Okay, where a and f are constants. Okay, we have been told to say a and f are constants. Find the dimensions of a. What have we been taught? We have been given this int, guys. Let me even change the color so that you may see clearly. You have been given this int to say, I think red is better. You have been given this int. I want you to read this int, guys. A trigonometric function appearing in the equation must be dimensionless. That means to say sine and everything here is going to be dimensionless. Okay. So since it is dimensionless, guys, that means we are going to remove, because we don't want dimensionless quantities there, so we're going to remain with x is equal to a. This is how simple you handle this kind of equation. That means now we have to find the dimensions of a. So the dimensions of a is equal to the dimensions of x, and the x is length, it is displacement, which is actually L. As simple as that. Okay, so guys, don't forget to register. Will help you clear all courses. A shape that covers an area. Okay, here's another question now. A shape that covers an area A as the uniform. Okay, this is an area A as a uniform height 8 and a volume which is given by area times height. Show that this formula here is dimensionally correct. As usual, guys, this is what I was showing in the other question. So volume now, guys, is given by L to the power 3. I've explained this area. And area is L to the power 2. What about height? Height is actually length. So we have L to the power 3 is equal to L squared times L. We're going to also have L to the power 3. So you can tell to say that this are all equal. So the equation is dimensionally dimensionally correct. What is the other question? The other question now is to show that the volumes now of a cylinder and of a rectangular box can be written in the form. Okay, Miss, let me check if I have another question of this kind. No, I don't have. Try to so let me try to erase this. Where is my rubber? I think I liked this question. It's somehow interesting. Okay, so here's how you have been asked to show. Okay, you have been asked to show the volume of a cylinder. Okay, if the volume of a cylinder and that of a rectangle can be written in this form. Okay, what you need to know is that the volume of a cylinder is given by pi r squared 8. Okay, now a cylinder, guys, a cylinder has a base area as a base of a circle, and the area of a circle is given by pi r squared. That means where there is pi r squared here, we are going to replace by a. So our a times 8. You even say NC shown because we've shown the area of a cylinder like that. Let's go ahead now and show the area of a rectangle if it can also be written in this form. Okay, so here's how you go about it. Our volume of a rectangle is given by L times B times 8. Where our L B, guys? Our L B is actually area. So where there is L B, now we're going to replace area because we have our L B as area of a rectangle. Guys, these are some of the questions, some of jokes, yeah, entertainment questions. So let's see the other question. Today we stand to end this topic. No repetitions. Done these questions too much. I mean this topic. We can't be doing a topic for years. Okay. The other question now, Newton's law of universal gravitation is represented by by this formula. Okay, where F is the gravitational force and M are masses. You should take note of this. And R is a length. Very important. The force as the SI units, you are very lucky, guys, have been given already the units of force. Okay, what are the SI units of the proportionality constant G? Okay, as usual, guys, since we have been asked to find the units of G, we are going to make G the subject here, the subject of the formula. What we do, guys, to leave G alone here, to get rid of the fraction, we are going to multiply by the reciprocal. So if we have A over B, guys, to get rid of this, we multiply by B over A. We just flip the fraction. So what we are going to do, we are going to, this is our fraction, this is our formula. We have our M multiplied by a small letter m there to show an object with smaller mass. So we're going to multiply both sides now by r squared over m times m. Same applies here. R squared over m times m. Our main focus is to get rid of this because you know that this and this are going to cancel and this are going to cancel. So our G is going to remain to be F times R there squared over mass times mass. Okay. What have we been given? We have been given the units of force to be kg. Okay, to be kg meters. Since there is a hover there, it's same as we can do that. It's same as taking to the power -2 there. You know what I mean by doing this. I showed you many times. If you didn't skip some hours, some minutes watching the video, you understand this. Okay. What about R? R, I've been told that it is length, okay? And length is measured in meters. Since now we have our R squared is going to be meters squared. What about M times M? Okay? We know that both are what? Are masses. And mass is measured in kg. So kg, it is kg times kg. So we're going to have kg squared. Let's go ahead and just replace in the formula there which you have been given. And see how simple we can simplify now the question. Okay, so here is how we do it now. We are going to say our G is going to be force. We have kg m power negative 2 there, times meters for r squared, which is meters squared, over kg squared. Okay, so what are we going to do next? What are we going to do next, guys? Kg, let me try, even maybe I change the color. So we have kg there and kg, so I'm going to remain with 1 kg here. Okay, what about m times m there? We're going to have m to the power 3, then raised to the power s to the power negative 2 over kg. So taking our kg on top, we're going to have kg to the power negative 1. It is going to gain a negative as usual. Then m to the power 3, then s to the power negative 2. As simple as this, guys. These questions are very, very simple. Another question, very important. We have been given kinetic energy to have the dimensions of this. Been given the dimensions of kinetic energy. Okay, the dimensions of kinetic energy to be kg meters squared, then s squared, as our dimensions of kinetic energy. Then we say that kinetic energy can be written in this form: momentum squared, then 2 times m is representing mass in this case. Okay, our first question is to find the proper units of momentum. Very important. Here is what we are going to do, guys. To make momentum the subject of the formula, we're going to say p squared there is going to be 2m, 2 times here we're going to have k multiplied by m there. To get rid of the square root, we're going to have our square roots of 2k kinetic energy times mass. Okay, now I want you to tell you something to say that any constant is dimensionless. So we're going to get rid of 2 by using that fact. Okay, because all constants are dimensionless. What have we been given, guys? I enjoy doing this, guys. So our mass is kg m squared, then s squared there. Okay, then we have been given now also multiplied by mass. Okay, mass is kg. So the units now, go ahead and do this. Kg times kg, you have kg squared, also m squared there. But since we have over here, guys, we are going to take it on top and it will become negative 2 there. Okay, as you can see now, both are raised to a power of 2, so the square root is going to cancel all these. Okay, so we are going to remain, the units is going to be now kg meters per second. Now since we have a negative, they are going to remain with a negative. As simple as that. Another question. Another question. Now, the question is, question B, refer to problem 5. Given the units of force. Okay, so we're going to find the units of force. That's what we are just asked to look for, question 5. So I just find we are going to do that on our own. Write a simple equation rating a force constant F exerted on an object an interval of time t during which the force is applied and the resulting momentum of the object P. Okay, yeah, I did the right thing here. At least I uploaded 2 questions. So let's do this, guys. Okay, what have been told in the question? We have been told to say we have been given the units of force, but in this case we're going to find our units of force, which we already know. Okay, if you want to drive mass times acceleration, because I don't like memorizing, where mass is kg, acceleration is meters per second square. Okay, these are the units of force. Let's go ahead now and find a relationship. Okay, this is where now we use dimensional analysis to find the dimensional analysis to drive formulas. You have to find the resulting momentum. Okay, so to find the formula for the resulting momentum, here is what you do. You are going to do this. You are going to say momentum now is going to be, what have you been given? I've been given force and the over time interval. So I'm going to say force. Now, force, you're going to raise force. This is what you do, guys. You're going to raise force to a certain power. In this case, I'll rate the power to be x. And our time is going to be raised to the power y. Okay, let's go ahead now and do some mathematical manipulation there. Momentum, guys, we are from finding the units of momentum, okay? The units of momentum which we found to be, let me check the units of momentum. Okay, I think I remember. The units of momentum is kg, meters, then s to the power negative 1. Okay, what about the units of force? The units of force is this. So I'm going to say kg, meters per second squared raised to the power x. Then our time, the units of time is second raised to the power y. As simple as that. Let's go ahead and do this now. Here, we bring like the way it is. So let's now distribute x everywhere. We are going to have kg to the power x, m to the power x, and s to the power negative 2x. Okay, then s there to the power y. Here we bring like the way it is. So now, here is what you do. Kg to the power x and m to the power x. Then s, okay, see this, s and s are multiplying. We are going to add the powers as usual. Negative 2x plus y. This is what we do. When we are multiplying two bases, like I said, you just add the powers. Let's say we have a power of a and b. We're going to have a plus b. This is what I was doing here. Why can't I change the color for his visibility? So here is what you are going to do, guys. We are going to do this. Kg is going to go with kg. Okay? Kg to the left hand side of kg, also to the left hand side of kg now, to the power x. What about hem? Hem, here is m to the power x. I thought the video had stopped recording, so sorry for pausing. I was almost feeling disappointed. I want to record this full video. Okay, so let's go to x. Okay, s here, it is raised to the power negative 1 is equal to s raised to the power 2x plus y. Now guys, what were you taught? You were taught that if a variable is raised to the power x, and here we also have 2 to the power, let's say for example 2, what you used to do, guys, you need to cancel this and used to remain with x is equal to 2, law of indices. So here, guys, kg and kd are going to cancel. Here we're going to say it is raised to the power 1. Okay, so when kd and kd cancels, we are going to remain 1 is equal to x. Here 1 and m will cancel, and 1 is equal to x. This even make more sense because x is everywhere to be going to be 1. What about here? We're going to cancel s, and here we're going to remain with negative 1 to be equal to negative 2x plus y. So let's go ahead and solve for y. Okay, solving for y, guys, we're going to replace negative 1 where there is x there. So we're going to say our negative 1 is going to be 1. We're going to put 1 here. 1 times negative 2, we're going to have negative 2 here plus y. That means our negative 2 is going to come to this side and it's going to be positive there. Then negative 1, as usual, is equal to y. Negative 1 plus 2, we're going to have our y to be equal to 1. So that means to say x and 1 are what? How equal to 1? X and y are equal to 1. So we're going to go now to the first assumption we make. Okay, so we are going to say our momentum is going to be, where there is f, we're going to put 1, guys, and where there is x, 1, and where there is y, also 1. So our momentum now is going to be force times time. This is the formula which you need to find. And this formula, guys, is going to become very true when we start doing momentum and collisions here. We are going to start this, I think topic topic 3 or topic, I think topic 4. Yeah, topic 4, topic 5. Okay, as usual, if you are tired, pause a video for 10 minutes. You give yourself a rest. And studying must be enjoyable. Don't be so stressful you forget everything. Have a commercial break. You can walk, you can take a walk, you can hear music. If you play FIFA, you can play FIFA. For you guys who enjoy FIFA, so let's do this now. So this is now exam question 2023. Okay, and we are going to do also this question step by step. Which two units are identical when expressed in terms of SI units? That's the question. Okay, so we are going to be driving the units. We are going to be converting. For example, say let's start with A. We have been given joule per coulomb. Okay, joule per coulomb to be equal to what? To be equal to, they have been given also joule per coulomb to compare it if it is similar to kg meter squared, then amps to the power negative 1 here per second. So what is joule, guys? Okay, a joule, I said what I said about work. I said that work is equal to mg8, and the units of work is given by kg, meter squared then per second squared there. This is what I gave, and I said that this is equivalent to 1 joule. So this is going to be replaced by kg meter squared then s to the power negative 2. Then what about coulomb, guys? A coulomb is given by amp times time. Okay, this is the amount of charge. Okay, this is the amount of charge. That's a coulomb, guys. You're going to understand this when we start doing electric field in semester 2. So there is still a lot to go. Still a lot to go through, guys. So this coulomb, as you can see, a coulomb is raised to the power negative. Okay, so what we are going to do is this. We're going to say kg meter squared then s squared. So now this is going to be raised to the power, since you have a negative, they are going to add to the power negative 1 to also to the power negative 1 here. So we're going to have a to the power negative 1, also s to the power negative 1. Okay, well, we can simplify our kg meter squared there. Okay, what about a? We have our a to the power negative 1, then s times s, we had the powers, which is negative 3. You can see that these units and the units which you have been given are not the same. Because they are not the same, you are going to conclude to say that question 1 is not the right option for us. Let's go to B. What have we been given about B? I've been given about newtons per meter, newtons times meters, to be compared to kg meter squared and s to the power negative 2 there. What is Newton, guys? Newton is just the units of force, and force is given by kg meters per second square there. Okay, so this is for n. Okay, this is for n, guys. So to multiply now by m, we're going to multiply by m here. That means to say our m and m, we're going to have m squared. So our kg m squared s to the power negative 2. Is this same to this? No, because of here we have a cube, here we have which is not equivalent. So this is also not the right option for us. Let's go ahead and do other question. So we're still looking for the right option here. What about C? Newton times seconds to be compared with kg meters per cubic seconds there. So what is newtons? As usual, this is for force. What about seconds? Okay, what about seconds, guys? Seconds is seconds we have s. Okay, what you need to know that, guys, where am I getting the units of force? Mass times acceleration, where our mass is for kg and acceleration is meters per second square, as usual as that. Okay, so here is what we do. So we are multiplying now by s here for seconds. Okay, so kg now meters. So since we are adding here, we are multiplying the here and here, it's same as we are adding now negative 2 plus here, it is raised to the power 1 here plus 1, which is negative 1. Guys, this is not similar to this. So even question C, option C is not the right answer. Let's try joule per second now. Joule times seconds to be compared with kg meter squared then. Okay, how do you go about this now? How do you go about this? Here is what you do. Joule is given by, this is actually for weight, and it is equivalent for kg, meter squared, then s to the power negative 2. Then second, we multiply by second. So our kg now is meter squared. Here we have a silent 1, so it is negative 2 plus 1. We are going to have negative 1. Now you can see that this is same to this. So our right answer is D. As simple as that. Very simple. We keep moving, guys. We keep moving. This is 2023, test 1. Okay. Here is the question we have been given. Okay, we have been given to say the metal sphere of radius r, okay, of radius r is dropped into a tank of water as it sinks at speed v. Okay, where sorry, I have been given also force. I'm too fast. The force is given by k r times v. Okay, and you have been asked to find the units of k. So to find the units of k, we make k the subject of the formula. We divide by r times v, then r times v here. So this and this we are going to cancel. We are going to remain, our k is going to remain with f over r times v. Excuse me, I'm having flu. Okay, so here's what we are going to do, guys. We can take this on top and we are going to gain negative. This concept, you should understand this. We're going to have r to the power negative 1 and v to the power negative 1. What are the units of force? The units of force is kg, meter per second squared. What about r? R is radius, so it is going to be meters, guys. Now raised to the power negative 1 there. What about velocity? Velocity is meters per second there. So we are going to have now, since it is raised to the power negative, that means here it is going to have negative 1, and the negative 1 is here, it is going to be positive, because negative 1 times negative 1 is going to be positive there. So let's go ahead and simplify this. We have kg meters times meters times meters. Here is what we are doing. Okay, so this is same as, because we are adding the powers, we have 1 minus 1 minus 1. Here, negative 1 minus negative 1 is negative 2, plus this one, we have negative 1 here. So we have m to the power negative 1. What about s? We have s to the power negative 2 times s there to the power negative 1, which is we are adding the power negative 2 plus 1, which is negative 1 here. So we're going to have our s to the power negative 1. Do we have any answer close to this or similar? Yes, actually our answer is C. As simple as that. As simple as that. So we go ahead now and step into conversion of units. Let's go ahead and do conversion of units. On the conversion of units, guys, you just need to know few things, guys. I'm going to encourage you to memorize this, to say 1 meter is equal to 100 centimeter. Okay, and 1 centimeter, guys, is equal to 10 millimeters. Okay, what about now 1 meter? 1 meter is going to be equal to 1000 millimeters, guys. Okay, 1 kilometer is equal to 1000 meters. You shouldn't forget this, guys, I beg. These simple things makes physics 101 to be difficult. Okay, what about 1 meter? 1 meter is also can be given by 139 37 watt inch. Okay, that's the conversion factor between meters and inches. What about 1 inch in 2 centimeters? 1 inch is given by 2.54 centimeters. So you need to know this in case you are not given in your test or exam, or especially quizzes. You can't be given this. Okay, what else do you need to know? 1 feet is equal to 0.3048 meters. Then 1 mile, very important because the next question will be on this. 1 mile now is going to be given 1609 meters. Okay, so I think now this is everything you need to know about length. Now about time, you need to know that what I can tell you, for what you already know, you need to know that 1 year is made of 365 days if we ignore leap year. Then 1 day is made of 24 hours. 1 hour is made of 60 minutes. And 60 minutes, I mean 1 minute, is made of 60 seconds. This, guys, you shouldn't forget. As long as you be doing physics 101 and chemistry 101, you shouldn't forget these things. So simple things I can show you to find now how many seconds are in 1 hour. You multiply this times this, you're going to have 3600 seconds. So a lot about conversion I'm going to show you when we start doing questions. So let's go ahead and start doing questions. So these questions, guys, are very important, and I'm taking this question from your recommended textbook. That's physics ones. I mean, cell physics, college physics there. 11th edition. It is the book you should be using at Mlungush University. Okay, very recommended even for you guys from other universities. It is also a very important book which you should be using for your first year natural sciences. So several carpet installers make measurements for carpet installation in different rooms of a restaurant, reporting their measurements with inconsistent accuracy as compared in table 1.6. Compute the areas for a banquet hall. Okay, B, the meeting room, and C, the dining room, taking into account significant figures. What total area of carpet is required for this room? So about significant figures, guys, we're just going to use what I taught you up from chemistry. The concept is one and the same. So how are we going to find the area of a banquet? So the area, guys, is going to be given. I'm going to multiply this. Let me change the color so that I may be pointing clearly. We are going to multiply this times this, okay? 14.71 times 7.5. 6. Our answer is going to be 109. Okay, our answer is 109.74 meters squared. But we have been asked to take into account of significant figures. So this is where now chemistry and the physics becomes interesting. You shouldn't go direct and give this as your final answer. When you are multiplying, guys, you count the number of significant figures in each figure. So this has 1, 2, 3, 4. It has 4 significant figures. Here of 1, 2, 3. It has 3 significant figures. That means to say our answer should be in 3 significant figures. So we can say 1, 2, 3 here. So we are going to stand here. Since this is greater or equal to 5, we're going to add 1 to this. We're going to have 110, which can be written in scientific notation as 1.1 times 10 to the power 2. As simple as that. Can add 0 here to show 3 significant figures. Okay? So our answer is going to be 1.10 times 10 to the power 2, like this. Okay. What about for the meeting room? As usual, the area we multiply 4.822 multiplied by 5.1. We know that this has 2 significant figures and this has 4 significant figures. That means our answer should be in 2 significant figures. So despite our answer giving us, guys, 24, because when I press this on my calculator, it's giving me 24.59 meters per cubic meter. So despite our answer be like this, we should leave our answer in 2 significant figures, and our answer is going to be 25 cubic meters, like that. Let's go to C. Okay, our C, as usual, we multiply 13.8 times 9. As you can see now, we have 1 significant figure there, guys. So our answer we are going to leave our answer in 1 significant figure. So my answer here when I multiply is going to give me 235 there cubic meters. But we want to leave our answer in 1 significant figure. So what we are going to do, we are going to multiply this. We are going to stand here. Okay? We're going to stand here and we are going to say 2 times 10 now. Okay, because we just need to leave 1 answer. Because we still remain with 2 figures there, we're going to raise to the power 2 here. So this is how you find question A, B, and C. What about D? D is to find the total area of carpet that is required for these rooms. So we're going to add this, this, and this. Okay, and adding this, guys, adding this is giving, wait, okay, so multiplying this and this is giving 124. Okay, pardon, it's giving me 124. Okay, it's giving 124.2, which in one significant figure, guys, we are going to write this as 1, because we want to remain with 1 significant figures. We are going to turn this into zeros, going to remain with 100 meter per squared, because zeros at the end is significant. So this is the value. So I went direct, guys, and so what we're going to do now is just to add the given values. We have 25 plus 100 plus 1.10 times 10 to the power 2 there. So once I do this now, it's when I'm going to get 235. Okay, 235. But our answer, guys, okay, our answer should be in what? Should be in 2 significant figures, as usual. Should be in 1 significant figures because of this one, which is as 1 significant figures. Because when we are adding, we follow the number of decimal places should be followed with the one which has the least number of decimal places. And you can see that this 100 as zero number of decimal places. So our answer should be in zero number of decimal places. So this has zero number of decimal places. That is the first point. The second point we are going to consider also one significant figure. So we're going to leave only 2 here. Going to leave only 2, then times 10 to the power. Now these significant 2 figures which has remained is to the power 2. Very simple. As usual, guys, if you are tired, take a rest. You are going to continue. Our aim is not to make you get confused. So I left this space. So I managed to answer from there, so it is fine. Okay, they like asking this question. If a car is traveling, this is when our conversion of units comes into effect. If a car is traveling at this speed, because this is the speed of a car, 28.0 meters per second, and the speed limit has been given to be 55.0 miles per hour. And the question is the driver exceeding the speed limit? We can't tell. Only if we are what? We have the same unit. So what we are going to do, guys, we are going to convert this into miles per hour. Here's what we do. We are going to use dimension analysis, okay, to convert units. Here's how you do it. You are going to do this. You are going to say 28. Now, here we have meters over seconds. We are going to multiply. Let's deal with meters into hours. Okay, meters I mean into miles, because meters should be converted into miles. What is the conversion factor between meters and miles? I told you to say that 1 mile is equal to 1609 meters. This is what I told you. So what you are going to do, guys, is this. Okay, this is what you are going to do. You are going to say, you are going to make units in such a way that they cancel. So I'm going to say for meters to cancel, we are going to have our meters down here, and 1 mile we already know is that is equal to 1609 meters. In such a way, meters and meters are going to cancel. This is how we convert. What about seconds? How are we going to remove seconds from seconds to hours? Here is what we do. Okay, to cancel seconds must be on top, and we know that 1 hour is made of 3600 seconds. So seconds and seconds are going to cancel. What have we remained with, guys, is 28 times 3600. Now on top we have miles there, over down here we have 1609 hours. So computing that on your calculator, you're going to get something closer to 62.6. Now on top we have miles. This division showing miles per hour. This is how you smartly convert units. Now let's try to analyze the two speeds. The speed limit on that street is this. This is the limit, and the driver's limit is this. This is the driver's speed. Okay, this is the speed of the driver, which we've converted from this to this point. Okay, now the speed limit, guys, on that street is actually 55.0 miles per hour. So you can compare that the driver here was exceeding the speed limit. The driver's speed is greater than this one, this speed limit. So I'm going to conclude to say that the driver was exceeding the speed limit. As simple as that. Let's keep moving, guys. we don't aim at anything today rather than finishing the topic. If it will take us to 2 hours, we have no choice. I want you, once you watch the video, you get covered, because we are heading to test 1. The traffic light green. What am I reading? The traffic light turns green, and the driver of a high performance car slams the accelerator. Okay, slams the accelerator to the floor. The accelerator registered. Okay, the accelerator becomes 22.0 meters per second square there. Then you have been asked to convert this reading to meters per kilometer per cubic per square minutes there. As usual, we are going to use dimensional analysis. White is reliable when I'm using a blue board. So here's what we do, guys. We're going to say 22. Then we have meters over second square there. To remove now, we want to get rid of meters. So we're going to say meters there down. And we know that 1 kilometer is equivalent to 1,000 meters. What about seconds to meters? So to remove seconds there, okay, we know that 60 seconds make up 1 minute. Okay, now we are dealing with second square. We are going to square this. We also square this. This is what you do. So as usual, this and this are going to cancel, and meters are going to cancel. So on top, we've remained with 22 times 60 squared, then kilometer over 1,000 meter squared, minutes squared there. Once you do this on your calculator, guys, you are going to get the speed of 79.2 kilometer there on top. Down you have meter squared. This is how you should be converting units in simpler terms. Then you start making those assumptions to say 1 kilometer is equal to, no, that is we've already said goodbye to semester. We've already said goodbye to secondary high school work. So let's see the following question. We see how we can handle also another question there. So the question reads, the diameter of a sphere is measured to be 5.36 inches. Find the radius of a sphere in centimeters. I want you to see 2 things here. This question involves 2 tricks. First, you have been given, okay, our first thing is that our measurements is in inches, and what you have been given, it is a diameter, and you have to find the radius. Okay, so first of all, let's convert this diameter into centimeters, since we have been asked to convert into centimeters. The conversion unit I gave, guys, I gave to say that 1 centimeter, okay, 1 centimeter here is equal to 5.36 inches there. This is what I gave. So what you are going to do now, okay, here's what you are going to do to convert now 5.36 inches. So we're going to write this in the form that these things may cancel. This is not what this is the question where I've been given in inches. Okay, the conversion factor, guys, sorry, the conversion factor is that 1 inch is equal to 2.54 centimeters. Yeah. So we are going to do this. I'm going to say we want to cancel this to cancel, say 1 inch. 1 inch there is equal to 2.54 centimeters there. So as you can see, inch and inch are going to cancel. We are going to remain our answer to be 2.54 times 5.36, which we are going to get our answer to be, when you multiply that, you are going to have 13.61 centimeters. So this is our question A. Our question B is to find the area of a sphere in square centimeters. So guys, the area of a sphere, that's why guys, you shouldn't forget too much about that topic, mensuration, because some of the formulas you won't be taught, but you need to know. So the area of a sphere is given by 4 pi r squared there. Okay, where our 4 pi r, now what is our radius? Okay, so what you have been given Hastings in the question A is to find the radius. So what we converted is diameter. So to find the radius, guys, we divide 13.61 divided by 2. You understand that the circle looks like this. From this point to this point is the diameter, and from the center to the circumference is the radius. That's why we are dividing by 2 to find the radius. And the radius now is going to be 6.81 centimeters. This is our radius. So where there is r, we're going to replace 6.81, then squared there. So our radius, our area, I mean, is going to be 5.28, then 0.29. In respect to the significant figures, our answer is going to be 5.28, then cubic centimeters. I mean square centimeters there. What about the volume? How do you find the volume of a sphere? The volume of a sphere is given by 4 over 3 times pi r cube there. So we go ahead and say 4 over 3 times pi. Pi is already on your calculator, guys. No need to stress. Then our r is 6.81 squared. Okay? So what we are going to do is to multiply out this. We are going to have the volume of 1321 cubic centimeters. As usual, we have 3 here. Okay, as usual, guys, like I'm always emphasizing you, if you feel exhausted, the brain always needs rest. You can try to give it a rest. 10 minutes is enough. Then you get back, you continue, so that you understand. You don't only watch videos for entertainment. You start from here. For those who are already registered, I show them how to watch my videos very well. Okay, so guys, if you need to pass physics, okay, if you need to pass physics, please register with us. WhatsApp me on this number. We will really help you to understand this. We will make sure we've already solved all the questions for you. All what you'll be doing is just to hot and ask at any time. Okay, when you go on my YouTube channel, guys, you're going to find videos which are maybe 8 videos, but my videos are more than 8 videos. All my videos can only be viewed by students who are registered, so you are missing a lot. Okay, on YouTube there are few which are offering notes according to those that are recommended at Murungushi University. So if you keep on setting on YouTube, you'll be wasting much of your time watching wrong videos. and that is possible, and that makes a lot of students to fail. It is time management. So you better watch videos from your lecture notes, from your past papers, from your tutorial sheets, so that after watching you'll be already covered. You just go direct and be ready to meet any kind of a question you're gonna meet. So don't forget to WhatsApp me on this number for assistance. We help you pass physics 101, biology, chemistry, and mathematics. Okay, we have been given the speed of light to be 3.00 times 10 to the power 8 meters per second there. Then you have to convert this in miles per hour. As simple as I'm doing, guys, here is what you do. Okay, we want to cancel meters, we remain with miles. We are going to say 1 mile there is made by 1609 meters. What about 1 hour? Wow, 1 hour. 1 hour is made of 3600 seconds. So seconds and seconds are going to cancel, and the meters are going to cancel. So what we are going to remain with is 3.0 times 10 to the power 8. We multiply by 3600 miles over 1609 hours. So you punch this on your calculator, you're going to get, okay, you're going to get something, you're going to get, mine is giving me 6.71 times 10 to the power 8, okay, miles per hour. As simple as this. Try to see the next question. If you can fill any question on this topic, I just don't know that question which will come, you fail, because in this video we've covered everything you need to know. Everything, I mean everything. So this question, guys, came in those last intake, the previous intake, 2024-2025 intake. This question came in test 1. Also in 2023 exam or test 1 it came. So they like asking this kind of question. So you are going to understand more about conversion of units. Here's how we go about it. Okay? Imagine that on your wedding day, I want to correct data. I like correcting data. Here, let me use white. Okay, on your wedding day, you are given a gold ring of mass. Your lover, you guys who are in love, you are given the gold, the ring made of gold, which has a mass of. So we're going to say mass of gold, which I'm going to call, let me call this M1. Since we have two masses, let me call this M1. Okay, let me just call this M1 to be 3.8 grams here. What else? What else you guys have you been given? Okay, you have also been given to say, M2 50 years later. Okay, 50 years later, since that your sweetheart gave you this, the mass was found to be 3 points. So you can see that there is a deduction. Okay, there is a deduction of some mass. Some mass was lost. 3.5 grams. Okay, and you have been given that. Now the question is on the average. So we can even say the time here. Let's consider the periods, 50 years. Okay, what have you been given now? On the average, how many atoms were abraded or weared off from the ring during each second of your marriage? This question now. Okay, we're going to do this question step by step. Now, in the question, we have been given to say the atomic mass, okay? The atomic mass, the atomic mass, the atomic mass is 197, okay? 197 mass unit number. This is stand for mass unit number, guys. Mass unit number here. Okay, now we are also being given to say one mass unit number is equal to 1.661 times 10 to the power negative 27 there kg. Okay, so guys, follow the steps. Okay, follow the steps like the same way I'm going to be doing the steps. So first, you know that there was a change in mass, so we're going to find the mass which was lost. Okay, we're going to find the mass which was lost, and this mass is going to be found by m1 minus m2. We are going to have 3.80 multiplied, or I mean subtract by 3.35. Wait, my god, my 2 is low. Okay, I'm going to be fast. Just pray that my battery don't go off till I finish. Okay, so here the mass which was lost is going to be 0.45 grams. Now we want to convert this into kilograms, guys. To convert into kilograms, we are going to have 0.45 times 10 to the power negative 3 kg. This is how you convert from grams to kilograms. Okay, you keep this in mind. Soon to use that. So let's now go ahead and find the mass of one god. Okay, let's find the mass of one god. I want to change the color here. Sorry for the gray. Okay, let me just use the orange because it is the only one which is available now. Or I may change the board also. Okay, let's do this. Let's do this, guys. What is now going to be the number? Okay, the mass of one god atom. The mass of one god atom. We have been given to say the atomic mass. So the mass of one god atom, guys, the mass of an atom now, one god atom, is going to be, because you have been given the atomic number, going to multiply the atomic number which you have been given 197 here, now multiplied, because you have been given to say that one atomic number, okay, we've been given to say, we were given to say that one mass unit number was given by 1.667 times 10, 61 I mean, times 10 to the power negative 27 kg. So to find the total mass, we're going to multiply these two, this and this, okay? Negative 27 there. Is it 27? 27 kg. So the mass of an atom here, the mass of an atom becomes to be 3.27217 times 10 to the power negative 27, negative 25 kg there. Okay, so since we have now have the mass of one atom, okay, we are going now to find the number of atoms which were lost. Just to follow the steps, guys. This is our step 2. Our step 3 is to find the number of atoms which were lost. And you are going to be given by this formula. The number of atoms is going to be the mass lost over the mass of an atom. The mass lost already, as usual, we know that the mass which was lost is given by, it's the one which we found in the first place. It was 0.45 times 10 to the power negative 3 kg over the mass of an atom is this which we are from solving here. Okay, so our number of atoms, as you can see now, masses are cancelling out. So our number of atoms, once you divide this, you are going to have 1.37523 times 10 to the power 21 atoms there. 21 atoms, because these are what? A number of atoms which were lost, which are braided off, which weared off from that ring. Okay, but the question, guys, is to find this number of atoms which were lost per second. Per second, from the time that BBB gave our, I don't know if it is our sister which was given that ring, up to 50 years. Isn't our sister old? I don't know. So, what we are going to do now is this. To find out the number of atoms which were braided off in seconds over this period, we are going to convert 50 years to seconds. Then we divide. Okay, we are going to divide into this. Let me check if there is still another board which is remaining here. This question is not for the week. Okay, it is only this part which has remained. So I'm going to erase. It's not a big deal. Erasing has never been a big deal since I started doing this. So it's just to erase here. We convert. My mouse is not working perfect. Can also erase here. So our aim is to convert 50 years. Okay. Can't see my penny there. Okay, we thank God. So 50 years. Follow this order, guys. We are using dimensional analysis. To cancel years, we are going to multiply over years, 1 year. And 1 year is made of 365 days. What about if you want to cancel days? We say 1 day there, down. This is the order you should be following. Then 1 day is made of 24 hours. To cancel hours, we say 1 hour is made of 60 minutes. And to cancel minutes now, we're going to say 1 minute is made of 60 seconds. So now you can see that years and years will go, days and day will go, hour and hour will go, and minutes will go. We're going to remain with 100 seconds. This is how dimensional analysis has made the conversion of units very simple. So we're going to remain with 50 times